Assalamualaikum. Today we would like to present to you about Lab Experiment 5 and 6, which is the GC and HPLC. Before that, this is our group member, consists of 5 people, which is Afiq, Zahirul, Nazruddin, Shafizam, and Faris. For the experiment 5, which is the GC, the objective of this experiment is to determine the retention time of TR of N-butanol and 2-propanol to identify the component present in a standard mixture on the TR, to identify the components present in an unknown sample, and lastly to determine the effect of temperature of TR and RS.
Hi, I'm Zahirul. The introduction for this experiment is gas chromatography is a process where mixture is isolated into its constituent by a gas phase that moves over a stationary phase. Gas chromatography is an analytical instrument that can measure the content of every component in a sample. Gas chromatography was typically used to test the purity of a particular substance and also can separate the mixture's component, which can help in identifying compounds. There are two phases in gas chromatography, which is mobile phase and stationary phase. Mobile phase is a phase which the substance can move, which is usually an inert gas, helium. It can also be an reactive gas such as nitrogen, while the stationary phase is a phase that doesn't move. It can be a microscopic layer of liquid or an inert solid. For the pre-lab question number 1 is define volatile compound, retention time, and resolution. Volatile compounds are compounds that have high vapor pressure and low water solubility. Retention time is the amount of time between the injection of a sample and its elution from the column. Resolution is the difference in retention time between the two peaks divided by the combined width of the elution peaks. Question number 2 is find the boiling points of N-butanol and 2-propanol. Boiling points for N-butanol is 117.7 degrees Celsius and the boiling points for 2-propanol is 82.5 degrees Celsius. Question number 3 is predict which compound N-butanol and 2-propanol will elute first in a gas chromatograph analysis. 2-propanol will elute first from N-butanol. This is because N-butanol have higher boiling point than 2-propanol. So, it will elute later than 2-propanol because of the higher boiling point. So, it will take the longer retention time.
Method or analysis of gas chromatography had 3 parts. Before continuing to method, these were apparatus and chemical needed for gas chromatography experiment, such as syringe, beaker, dropper, propanol, butanol, and unknown sample. The first part of method is sample handling. First of all, the syringe must be rinsed first before filling it with the samples, and make sure that the volume of sample is more than required volume. Please make sure that there are no air bubbles in the syringe. To remove the air bubble in the syringe, we must tap the syringe gently. Second one is hold the syringe vertically and push the plunger to the required volume at eye level. Remember that the samples are volatile, so the preparation and injection of sample must be done quickly. For operation of gas chromatography, firstly, inject the sample into the septa for manual injections. Check the oven column, make sure that the instrument is in off mode. Allow the instrument in window screen to set up itself. Then click the method and edit the entire method. If samples in high concentration, choose split, while choose split less if concentration are low or less. Follow the methods and save the methods. Please make sure that there are no bubbles appear in the syringe. For the next sample, click Data Analysis and repeat step 11 to 13. We proceed to data analysis. As you can see, this data of retention time of peak and peak width of different temperature. The temperature is a very important parameter to influence separation. As rule of thumb, for every 15 degrees Celsius higher or lower, the retention of a column decrease or increase by a factor of 2. That means, if the last peak elutes at 100 degrees Celsius after 10 minutes, it will elute at 5 minutes at 115 degrees Celsius and at 20 minutes at 85 degrees Celsius. As you can see, the retention time of peak was reduced to higher temperature. Next, the table shows the retention time of different solutions. Retention time depends not only on the structure of the specific molecule, but also on factors such as the nature of the mobile and stationary phases, the flow rate of the mobile phase, and dimensions of chromatographic column. Retention time is usually characteristic for a specific compound in a given separation.
Hi, I'm Afi Iskandar and I will continue with discussion. In this experiment, retention time plays a big role in analyzing the sample in gas chromatography. For the first part of the experiment, retention times are differentiated according to the number of carbon, molecular weight, and the boiling point of the samples. Graph plot from this reading that obtained from the chromatography show that log T is proportionally increased when number of carbon is increased. It goes the same with molecular weight and boiling point. Log T increase when the molecular weight and boiling point of the compound are increased. This data concluded to the relationship that when the number of carbon in sample tested increase, their molecular weight also increase and so on their boiling point. Therefore, the retention time for a maximum of symmetrical peak to occur is also increased. Next is the temperature change during the experiment of GC affected on T and R. The higher the temperature was set, the longer it take for the compound to elute. Therefore, the resolution will increase, resulting the increasing of the efficiency. During the experiment was conducted, there were several precautions to be taken in order to minimize errors in the data. Firstly, shake all the solution adequately to ensure dissolution for 5 minutes before injection into chromatograph. Then, make sure the column is not clogged. It may be caused by the precipitation of proteins in the column, caused by removal of stabilizing agents during fractionation. Besides that, the syringe was rinsed and cleaned before and after each sample was injected to prevent any contaminant and other solution that will affect the process. And lastly, avoid formation of bubbles during the experiment because it will affect the reading in the column where the measurement was taken. Thank you.
My name is Shafiz Hakimi and I would like to continue the presentation with the conclusion for experiment 5. As a conclusion, the types of compounds which are suitable for analysis using gas chromatography must possess appreciable volatility at temperatures below 350 to 400 degrees Celsius, able to withstand high temperatures and be rapidly transformed into vapor without degradation or reacting with other compounds. Flame ionization detection (FID) is a suitable detector for this analysis because it senses carbon ions, which allows it to detect virtually any organic compound. It also has high sensitivity and wide dynamic range. There are two factors which can increase the efficiency of a GC column, which is column pressure and the column diameter.
Next, we will move to experiment 6, which is the HPLC. The objective of this experiment is to determine the retention time of the standard solution, which is the caffeine. Second is to identify the caffeine peak in a soft drink sample. And lastly, to determine the amount of caffeine in soft drink sample using the response factor method.
Hi, I'm Zahirul, and I will be presenting the introduction for this experiment. The introduction is high performance liquid chromatography, or HPLC, is a type of separation analysis that include the uses of liquid mobile phase and liquid stationary phase. Differences in the polarity of analyte will occur during separation. The analyte that interacts most in the stationary phase will elute later than the analyte that elute later as cause at least interact. Reverse phase chromatography being used when the stationary phase is a non-polar while the mobile phase is the polar mixture. The changes in the mobile phase polarity will affect the interaction between the analyte with the stationary phase and also affect the efficiency of separation. Changes in the mobile phase composition can be done either by isocratic elution, whereas the composition of the mobile phase is constant throughout analysis, or by gradient elution, in which the composition of the mobile phase is changed during separation either continuously or in step in order to separate wide range of polarity of the analyte. For the pre-lab question, the first question asks, define normal phase partition and reverse phase partition HPLC. Normal phase partition is a specific type of partitioning chromatography where the stationary phase is polar and the mobile phase is non-polar. Meanwhile, reverse phase partition HPLC is opposite from normal phase, which the mobile phase is more polar than the stationary phase. The second question is, what is meant by response factor? Why is response factor important in determination of the identified and the amount of an unknown? The answer is, the response factor can be defined as the ratio between the concentration of a compound that being analyzed and the response of the detector to that compound. Response factor is important because it is an alternate method for determination of the quantity of the impurities present, and amount of the unknown can be calculated with the help of peak area of the component.
Before starting the methods, these were apparatus and chemical needed for HPLC experiment. Firstly, experimental. The standard solution was divided to two solutions, which is stock solution and working solution. For sample preparation, 10 ml of soft drink was poured into the beaker. Magnetic stirrer was used to remove any carbonation, then filter it to remove particulate matter. Then inject the solution B to HPLC to establish the retention time. Measure the peak area of caffeine. The step was repeated with soft drink sample to measure peak area corresponding to caffeine. Before starting the methods, these were apparatus and chemical needed for HPLC experiment. Firstly, experimental. The standard solution was divided to two solutions, which is stock solution and working solution. For sample preparation, 10 ml of soft drink was poured into the beaker. Magnetic stirrer was used to remove any carbonation, then filter it to remove particulate matter. Then inject the solution B to HPLC to establish the retention time. Measure the peak area of caffeine. The step was repeated with soft drink sample to measure peak area corresponding to caffeine. For operation of HPLC, the system was switched on to operate the instrument. Method was created and click the pump icon on pump window. Oven temperature was set 28 degrees Celsius. Do not change anything at status log menu. Click download and apply at time program menu. Select LC Setup Assistant icon. Insert appropriate data in multi-menu and fill in ratio menu, then save. Click the LC Setup Assistant again to proceed with injection. The maximum volume while filling the shrink should be 20 ml. Result will show chromatogram with several peaks depends on sample composition. For sample preparation of HPLC, use the shrink and filter it to transfer sample into a vial. Filter mobile phase to prepare it. Ultrasonic cleaner was used for sample injection. Click single run acquisition. Print the result after extend run, view and method custom report. For cleanup process, click LC Setup Assistant and lastly, switch off the instrument. Now we proceed to data analysis. The table shows the standard compound with retention time and base peak. This data is valuable because it can be used to compare retention times of different compounds. This method only works when the compounds have unique retention times under the different temperature. When the retention times of the components are very similar or extremely different, not every compound will be seen in the chromatograms. When solvent polarity is varied throughout the run, this is known as a gradient run. Gradient conditions can be optimized to improve the chance that all the components will be seen on the chromatogram. While all the retention times are not as comparable due to varying conditions, it is useful to see how many compounds are in the mixture and characterizes the compounds. During an HPLC analysis of a mixture, the compounds will separate based on their retention times. This will produce a chromatogram. An example of a chromatogram can be seen in the slides. Either the peak height or the peak area can be used to estimate the concentration. This can be done because these values are proportional to the concentration when the peaks are sharp and the flow rate is carefully controlled. A calibration curve can be prepared by plotting either peak height or peak area as a function of concentration. Last but not least, we can calculate the concentration of caffeine.
As a conclusion, the types of compounds that are suitable for analysis using high performance liquid chromatography or HPLC was able to be identified, which is any compound with solubility in a liquid that can be used as a mobile phase. The differences between high performance liquid chromatography and gas chromatography was identified in terms of mobile phase and column. For the HPLC, the mobile phase is liquid and it has pressure and gradient, while for GC, the mobile phase is gas, and it has no pressure and no gradient. The column for HPLC is short and wide, while for GC it is long and narrow.
That is all from us. Thank you.